Morning, everyone. I'm sorry for bad network connection yesterday. We couldn't do a comprehensive interview tutorial that yesterday due to bad network from my end. So I decided to do the makeup tutorial for detailed explanation and then measurement of soil and waste pipe installation and measurements. So I will start with site layout. Is the site layout showing the running of pipe to this building and the gatehouse. So as we said yesterday, the side of this chamber is 600 by 600 chamber. So let us use it as a basis for our measurements on this plan. 600 by 600. Okay. So I want to take off for this rainwater pipe. 200 rainwater pipe. I said explained yesterday that most of the time, or mostly, they normally use PVC pipe for soil and waste, or rainwater pipe as to a water supply pipe. They normally use PPR, which is 4 meters, and we have different types of PVC pipe. We have one of 6 meters, we have one of 2.7, 3 meters, 2.8, depending on which manufacturer you are buying from. So for the sake of this tutorial, I'll be assuming we are using 2.7 meters PVC pipe. So let me start with measurement of rainwater pipe installation. We click on this linear tool and put 200 mm PVC rainwater pipe external. PVC rainwater pipe external. So we click OK. So I will start my measurement from inner face of this chamber because this pipe is going to enter a little bit. So I'm just trying to know the total length of this rainwater pipe. 200 mm rainwater pipe has been laid underground. They are all underground pipes. Okay, so let me consider this side to 200 mm rainwater pipe. Okay, since we've considered all the 200 mm rainwater pipe, so having done this, I will drop the tool. So we are left with 100 mm soil and waste pipe. click this one too. 100 mm PVC service pipe external. Click OK. So we have it from here. Being discharged to sewage treatment plants. Okay, we've considered all the 100 mm pipes. So remaining 50 mm pipe, though it's not named, you see all these yellow pipes. They are all 50 mm. If you check the ground floor, you agree with me that they are all 50 mm pipe, the yellow pipes, you see. So you have to consider that on external, on this layout. So click on linear tool. So 50 mm waste pipe external. All these ones, they are all 50, supplying WC. I mean, they are supplying wash and basin, sink, floor drain. So just know that all 100 mm pipe normally supply WC, while 50 mm supply wash and basin, kitchen sink, and floor drain. So having considered all the pipes on this layout, so we are left with fittings. So let us consider fittings to this rainwater pipe. But in some cases, they don't normally use sockets to connect these external pipes. They normally eat the pipe in such a way that another pipe will enter. But for the sake of this tutorial, so let me just calculate for socket. So 200 mm socket for this rainwater pipe. So I will copy this quantity for 200 mm pipe and paste. It's copying, it's still copying, it's trying to load. It has copied. I will double click on the copied one and change the name to socket. So click on this advanced to divide the quantity by the length of pipe, which we said we should assume 2.7 bracket plus 1. So don't forget to change the unit to number, which is EA. So that means we'll be needing 17 number of sockets to connect this rainwater pipe. So for 100 mm pipe, we'll be needing socket for that one too. We copy it, paste. Okay, just copy it. Let me. So socket. Click on this advance. Divide the quantities by 2.7 and add 1. So change the unit to number. So what of 50 mm? So we won't be needing socket because the quantity is small. One pipe will be enough for this one to connect. So there's no need to consider for sockets. And again, you see all these short pipes connecting to this building, they are going to rise up like this. Let me show you an example. This like this one, you see all these short pipes that are the one connecting, feeding our sanitary appliances inside the toilet. So all these sorts of pipes, they are going to rise up. The receive socket, the receive elbow from the bottom, and at the top, the receive elbow too. That means on that short pipe, one pipe will be having two elbows. So these are the short pipes connecting to the building. These are the pipes underground. All these one, they are stack pipe. They are all stack pipe. So all these short pipe will be having, will be rising up to feed our sanitary wells. So how many short pipe, 100 mm short pipe do we have? We have one here. We have two. We have three. We have four. We have five. We have six. So I'll be adding 6 by, let us assume the height in which the rise is 200 mm. So I'll be adding 6 by 600 mm to these quantities of 100 mm pipe. So sorry, this socket. So we had plus 610 0.2. Okay. So I'll click OK. So what of this 50 mm pipe that's been rising up? So we have 1, 2, 3, 4. So I'll do same to these 50 mm pipes too. So plus 5, 10, 0.2. I will click OK. So don't let us forget the excavation for all these pipes. So I will just excavate for rainwater pipe. I will copy these quantities. Okay. So excavation for 200 mm pipe. So out of 400 mm pipe, so I will copy this one too to know the running length of our excavation for 100 mm pipe, because they are being laid underground. So that's copied. So excavation. But don't forget that all the rising pipe, they're not going to be underground. So you have to remove these ones from your quantities when you are calculating for excavation, because they are not going to be underground. So you just click OK. So what of a 50 mm pipe? I'll click copy, paste. So excavation for this 50 mm pipe. So same thing for this one. You have to remove the rising pipe for 50 mm because they are not going to be underground. Okay. So we have to consider elbows, because as they are rising up, they are going to receive elbow. They are connected to this manhole. As they are rising up from here, they are going to receive elbow. So 100 mm. So it could be 45-degree elbow or 90-degree elbow, but I would prefer we use 45-degree elbow, because for easy flow of water, so that the bend will not sharp, we will not have sharp bend. So I will consider 45-degree elbow. So click OK. For 50 mm, you have 1, 2, sorry, 400. You have 1. Okay, let me check. Okay, this one is 50. This one is 100. So, so we are only considering for 100 mm elbow. So let us continue. Up to 3, 4, 5, 6. So that's that for 100 mm degree elbow. What of 50 mm degree elbow? So 50 mm elbow, 45 degree. So mind you, whatever the size of pipe is, that's going to be the size of their fittings, except they are reducing, or except bigger pipe is connecting to smaller pipe that you are going to consider reducing fittings. So click OK. So we have one here, we have another one here, we have one here, we have one here. So that's that for 45 degree elbow. So what of our manholes? Manholes. So we have to know the total number of our manhole. So the size of this one is 600 by 600 CB. So just to know the total number of this manhole. So trying to know the total number of chamber for basin. It's for rainwater pipe. So that's that for this manhole. 600 according to their specification. This front page, the size of the manhole is 600 by 600, as you can see here. 600 by 600 rainwater cache basin manhole. So we are left with water main manhole, which is 450 by 450, same as soil manhole, 450 by 450 soil manhole. So let us consider those ones too. So we are left with sewer manhole. So they are 450 by 450 mm sewer manhole. Click OK. We have one here. We have one here, one here, one here. We have one here, we have one here. Seems that's all for sewer manhole. Okay, we have another one here. We have one here. We have one here. Okay, that's that for manholes on this site layout. I think we've considered all the necessary things we need to consider on this site layout. So let us move to ground floor. So this is the ground floor. This is the ground floor. Sorry, when we are doing water pipe installation, I regarded these two appliances as wash and basin, but they are not wash and basin actually. I later discovered that they are not wash and basin. They are urinal. They are urinal where you can urinate on. So it's all these ones, they are wash and basin. These ones, they are wash and basin, but this one is urinal. So let us recognize, try to read or interpret this plan for better measurement and understanding. As you can see, this arrow is 50 mm diameter soil waste pipe from above to below. That means it's connected to stack pipe. This pipe, they are connected to stack pipe. So these are the stack pipe. As they are coming now, they are connected to this stack pipe. And at the top of this stack pipe, we are going to have elbow, or in some cases, they used to apply directly, fent cowl. So let me show you the image of vent cowl. So this is the vent cowl. It's going to be at the top of the stack pipe for ventilation. So the yellow pipe, they are all the yellow pipe. The yellow pipe is 50 mm water pipe at low level in the wall. So all these ones, they are 50 mm pipe. As I said earlier, that 50 mm pipe normally used to run or to supply or to remove wastewater from either we have sink, wash hand basin, floor drain. They normally use 50 mm pipe, but for water closet, they normally use 100 mm pipe. So let us measure for our 100 mm pipe, which is this red. All this red, they are all 100 mm pipes. So let me scale this page to set our measurements. So that's the size of wall. So let me cross check from here. Okay, so let us consider 100 mm pipe first. I click on this link. So say 100 mm PVC pipes on ground floor. I click OK. So it starts our measurement from here. So this one, they are all 100 mm pipes supplying WC and the urinal. Since we've considered all our 100 mm pipes we have on this ground floor, we drop the tool. But mind you, all these pipes, they are being connected or being fed by stack pipe. If you read this, there's a 50 mm soil pipe. There's error on this interpretation of the pipe, because this can be 50 mm, it's 100 mm pipe. They're all 100 mm pipe. They are 100 mm pipe. They are all 100 mm pipe according to the site layout here, or the red pipe. They are all 100 mm pipe. As you can see, they are being connected to the building. So they are all 100 mm pipes. They are all 100 mm pipe. So they are all 100 mm pipe. I'm trying this yellow pipe that connected them together. I'm trying to check. They call this 100 mm vent pipe at low level in the wall. Okay. What they are trying to say is that this one, it's connected to stack pipe. And from here, this one is connected to stack pipe. So by 100 mm vent pipe at low level in wall. So there's horizontal vent pipe feeding from this stack pipe where this WC connected to. So you have to consider this yellow pipe too, or we consider it separately. So 100 vent pipe. So 100 mm vent pipe ground floor. So we have one here. We have it here. So that's all for vent pipe. So, and don't forget, as you can see, they say 100 mm solid waste pipe from above to below, terminate at higher level vent cowl. That means this one is being connected to stack pipe. This is the stack pipe as I shown earlier. This is the stack pipe. So, and the height of our stack pipe is going to be determined by the height of our building. So we'll be having one stack pipe here, another one here. So that means we'll be adding 2 by 3 meters to the quantities of our 100 mm pipe. Or let us take it separately. So just say 100 mm PVC stack pipe ground floor. So we'll be having it in 2 places. Just multiply our quantity by 2 and click OK. And you know, the stack pipe is not showing on the plan, so we have to measure 3 meters somewhere on this plan. You show whatever you measure is 3 meters. If the height of a building is 3 meters, so you consider 3 meters. So this 3 meters. So that's that for stack pipe. So what of fittings to 100 mm pipes? So our 100 mm pipes. So we will be having elbow here, be having T here. So let us consider 100 mm elbow first. So we having 100 mm PVC elbow ground floor. So it's going to be, so we'll be having one elbow here. Sorry, I pick wrong two. Pick wrong two instead of picking count 2. So 100 mm elbow ground floor. So click OK. So you have one elbow here. Where again do we have elbow? So we don't have elbow. Okay, so we have T equal T. So 100 mm equal T ground floor. Click OK. So we have 1 equal T here. 1. Since that's the only place we have 100 mm equal T. And as to this, we'll be having YT here. Let me show you the section of this. As you can see on this section, you see this is how this pipe is being connected to this stack pipe. This is the YT, how it's connected to the WC. You see, this is the lavatory basin, wash hand basin. It receives elbow, it carries elbow. So let's go back. So here now we'll be having YT here, YT here, for it to be connected to stack pipe. So click count. So you say 100 mm YT ground floor. Click OK. We have one YT here, another one, sorry, another one here. So making 2. So making 2. So which fitting do we, so we'll be needing 45-degree or 135-degree elbow here. 1, 2. So 100 mm 135-degree elbow on floor. So we have one here. Since that's the only place we have 135-degree elbow. So that's that for, okay. So as I said last time, that I will be considering pan connector. there used to be pan connector connecting receiving pipe from stack pipe to connect to our wash and basin. So the number of wash and basin, you want to determine the number of pan connector. So I consider pan connector to WC2. So pan connector ground floor. So total number of WC wash and basin or urinal. We have 1, 2, 3, 4, 5, 6, 7. So that's that for our pan connector. And another fittings we'll be needing when we are considering WC or lavatory basin, we'll be needing adapter. We'll be needing adapter. Like, let me show you. Let's see section here. So you can see this. So let me use this kitchen sink as an example. As you see, some used to call it PVC coupler instead of calling it a reducing adapter. So for kitchen sink, they normally use 50 by 40 diameter PVC coupler, but it's not showing on this WC. It's not showing on this WC. It's not showing on this WC. Some used to call it coupler. So on all our lavatory or WC, we considering PVC coupler. So say 50 by 40 PVC coupler or rubber reducer. So we have one here, one here, one here, one here, one here, one here, one here. So that's that for fittings as regards to WC and urinal. So we are done with 100 pipe. So let us move to 50 pipe. All this color of this pipe. So I'll click on linear 2. Okay, before I move to this, as I said earlier, most of the time in soil and waste pipe installation, they don't normally use sockets. They normally they will eat the pipe in such a way that another pipe will enter. So, but for the sake of this lecture, let's consider sockets. So for 100 pipe, so for 50 pipe, 50 PVC pipe ground floor. Click OK. So these are our 50 pipes. So 50 pipes. Okay, we've considered all our 50 pipe. I've dropped it too. So let us consider fittings to this 100 pipe. First of all, elbow, 50 degree, 50 PVC elbow, ground floor. So for here now, we'll be having elbow here, elbow here, elbow here. Seems that's all. Click, drop the tool. So let us consider T equal T, 50 mm PVC equal T ground floor. So I will click OK. So we have one T here, 50 mm T. We have one here. So that's that for T. So what of 45-degree or 135-degree elbow? We have one here too. So 50 mm, 135-degree equal T ground floor. So we have one here, one. So I drop the two. So if consider all the pipes as regards to 50 mm pipe and their fittings. So what else do we need to consider? We need to consider rubber adapter for this one too. But the size of rubber adapter they normally use 50 by 40 mm, 50 by 32 mm rubber adapter. So I click count. So 50 by 32 mm PVC rubber adapter. So click OK. So they having one here, another one here, one here, one here, one here. So that's that for rubber adapter. So what of the needing bottle trap for all this our wash hand basin? So click count 2. So bottle trap ground floor. I will show you the image of bottle trap. 1, 2, 3, 4, 5. So that's that. So let me show you the image of bottle trap, how it's been connected to wash hand basin. As you can see here, you can use sink or okay, this is the bottle trap being connected to waste piping that's connected to this wash hand basin. This is the bottle trap. This is the bottle trap. So I think we've considered all the necessary fittings and pipes, installations as regards to soil and waste pipe. I believe you understand all what I've been explaining as regards to soil and waste pipe installation under this section. So, okay, flood drain. We have flood drain. Let us count the number of flood drain we have. So, we have 100 mm flood drain. Click OK. So we have one here. We have another one here. We only have 2 flood drain on this plan. So I think we've considered all the necessary things as regards to soil and waste pipe installation. Okay, before I forget, we have to consider fence cowl at the top of our stack pipe. And we have 2 stack pipe. We have one here, we have another one here. So 100 mm fence cowl. Okay, so we have one here and that one here. Click OK. And in some cases, they used to apply elbow. So it's from that elbow, the fence cowl is going to be connected to us. In some cases, they don't use to apply elbow, they will just apply fence cowl directly to the stack pipe. But as a concept here, let us consider that elbow too. So 100 mm 40-degree elbow to stack pipe. So I click OK. So that one is going to be 2, number 1, 2. So that's that for sun and waste pipe installation. So let me check, let me quickly rush whether there's AC plan. There's AC plan, so just consider AC 2. Or there's no AC, so we'll consider AC under electrical surface installation or next time. So it is AC. Okay, let me rotate this now. Oh, I cannot rotate it to, I don't know why. I have to rotate for easy measurements. So the rotation tool is not showing. I don't know why it's not showing. Should be able to rotate this page. I cannot rotate this. So that means we will be having this installation when we are considering electrical installation. So I believe you gain 1 or 2 things as regard to solar and waste pipe installation. Thank you for watching. Have a great day.